Do you want me to read question 9 or 8?
Yeah.
So which relationship would result in failing to reject the null hypothesis? So I'm in section 4.5-ish.
Okay.
And I think maybe, possibly, there might be something here.
Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance or that thing. Use this information to answer the next 2 questions. P-value to the level of significance. Okay.
Okay, so when we're failing to reject the null hypothesis, that's a type 2 error. So we just need to see what the symbols are for a type 2 error. Okay, it has to be something with the A-looking thing.
Yeah.
It has to be one of those 2 from the information that I read, but it mostly just talks about the type 1 error. It doesn't really talk about the type 2.
Mm-mm.
So why don't we just do you try 1 and I try 1?
Okay, which one are you going to try?
I'll try to eat the p-value.
Okay, and I'll try the other one. Eat.
Okay.
That's looks like a fish.
So I think we're gonna have to do the same thing on question 9, though.
Ew.
Which
relationship would result in injecting the null hypothesis?
Do you want to just do the same thing?
We can. I'm going to keep looking, though. I don't know where else it would be in the chapter. But hold on. What is question 8 asking again?
So basically we need to, it's which relationship would result in failing to reject the null hypothesis, which is a type 2 error.
Okay. Oh, it's I just found something that I think might be the answer, but I gotta use my brain. Which relationship would result in failing to reject the null hypothesis? So it's when the p-value gets eaten.
Okay, so then the next one would be that the little a thing gets eaten?
I think
Because it's
so,
just
because
the opposite.
yeah, so if you go to the part where it says 5 worked example perceived health after a cardiac arrest, it's kind of towards the bottom of the chapter.
Mm-hmm.
And then it has the answer the following questions thing in the blue box.
Right.
If you go to step 4, 28 and 29 and 30 are all, well, I guess just 29 and 30 kind of answer that question, don't they?
Okay, since the p-value is greater, so I think, yeah.
Right?
Okay, so question 10. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. So then question 10 says, which of the following would be the appropriate alternative hypothesis? So it would just be is greater than? Because they say they're concerned that the true mean is actually higher than this.
Yeah.
So I would assume that the average claim amount is greater than 1,500 then?
Yeah.
And then for the null hypothesis, would it just be the average claim amount is equal to 1,500 for question 11? Because I think the null is like you believe it until it's proven wrong, and then the alternative one is,
Yeah.
then you test it from there.
Yeah, and that's what they believed, right? That all the claims were like around 1,500.
Yeah.
Okay.
Okay, so the next information is the insurance company randomly selects n equals 40 claims and calculates a sample mean of $1,650. So the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Just off the top of my head, I would say yes, because it's larger than 30. So I'm gonna assume it is a good assumption since the sample size is large.
Yeah.
Okay. So what theorem of law justifies your answer to the previous question? Law of large numbers?
Yes.
I
I
think.
think so.
I'm
Still
rolling.
kind of,
Emily, the faster we can get this done, the better. Which of the
which
following is the test statistic as defined in this lesson? Test statistic.
is statistic? Nobody knows.
Oh, maybe not.
Is it Z? Is Z an option?
Well, that's kind of what I'm getting confused about. It looks like it might supposed to be. Okay, surely.
Where Z is the test statistic, right? In 4.2?
Wait, did you find that?
Yeah. If you scroll up to 4.2 in the content tab or whatever.
Okay. Since we know. This is called a test statistic. I guess so. Let's roll with it.
Okay. How many questions are there on this one? Oh my gosh.
21. So we've still got a little bit. Okay. So okay, so now we actually have to do some math. So we have to find the z-score associated with this test for question 15.
Yay. This looks like it's going to be done differently though than.
So I found it somewhere. Okay, so if you go to step 4 of number 2, it's really close to the beginning. It shows a similar, well, actually the same exact equation that we've used in the past. I think that's what we're supposed to do.
Yes.
It almost seems like we do it the same way though, because
I'm just confused on what, we're not given a standard deviation. Notice the weird fish A looking thing. Is that what you use for your standard deviation?
Maybe. I'm gonna look.
Probability. We're given the X still.
That, oh wait, that's not the same thing.
Given mean.
What are you, you weird little creature, you?
Oh, it's the standard deviation of $40. That's my fault. I didn't read it right. We're given the standard deviation.
It'd probably be good if we knew what that little symbol was, though.
Yeah. I need
But
to
I
think.
guess we don't put it in anywhere.
Okay. Yeah, I think we just find it like normally. So I got negative 0.15.
Okay. I'm coming for you. Okay, same here, negative 0.15. All right. Okay, so what is the p-value associated with the z-score from the previous question? So I think this is where that other equation comes into play. That is in the step 4 section.
I don't know if I'm looking in the right spot.
So it's under like it's under like section 2, the Ethan Allen, and then
Okay.
you go down to step 4.
Oh, so to find the p-value, we first calculate the number of standard deviations that x is away from the assumed value of true mean 140 pounds. This is our z-score. Then we use the applet to determine the probability of observing a value of z that is large or larger than the value we observed.
So do we just stick that number into the applet?
Yeah.
I'm just a little confused. We didn't use the same exact formula that they have above.
But we couldn't because they didn't give us an n, did they?
I don't think so. No, they didn't. So I guess just put it in the applet. Roll with it.
And there's a bunch of stuff about scientific notation, and I don't know if you saw that, but I guess we'll deal with that when we get there.
How do we know what to highlight though, or what to shade?
It said large is as large or larger than, so I think it would be from negative 0.15 and past. So everything right of negative 0.15.
And the right side.
Yeah. That was an easier way to say yeah.
You can. So then we just use the area for our answer?
Yeah, and I got 0.560.
I got 0.5596. I don't know if that's.
Yeah, so,
matters?
Did I round up too much? No, I just rounded up.
Oh, yeah, we have to. Okay, that's. Just not watching those little things.
Oh, I hope this is right.
So what inference would you make about the null hypothesis for this problem? Great question. What would we say?
Failed to reject the null hypothesis? That was just a guess on my part.
Let's do it. Okay, so now we have to say whether we have sufficient evidence or not about this population mean being 150.
So if you go back to that part we were just in with the p-value, it talks a little bit. Shot my pencil.
So I guess what numbers should we be comparing though?
Yeah, I need to reread the historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypotheses. So she thinks the average has decreased.
So actually,
what?
I think what we're doing, I think I figured it out. So, well, not figured it out, but kind of figured it out. So it's comparing the population mean with the sample mean, and that's how, at least in step 4, that's kind of what it's doing to compare. So what we need to do, so it looks like 144 and 150 are the numbers that we're comparing. So that's a $6 difference between the two, between the population mean and the sample mean. So
and they do, and I was wrong when I
support the true population or not? What?
Well, I think that our numbers are going to be wrong because that 36 sales receipts, that would be our N. So when we thought it was weird that we weren't using the hypothesis, or not the hypothesis, the formula like it showed in the book, we are supposed to use that formula because that's the 36.
So should we go back?
Yeah.
So let's take a slight turnaround here.
I need to get a calculator.
But Emily, what is that A thing and the O thing that represents standard deviation? Are we assuming that's the same thing?
No, the standard deviation.
Oh no, it's the
$40.
$40.
Yeah. I can't calculate anything because my calculator won't turn.
Okay, I'll do this a couple times. Get some.
Okay. I'll keep
Hopefully
working.
it's accurate.
Oh, it did it. We're good.
Okay. I got negative 0.9 this first time. I'm getting the same thing too, so just let me know what you get and we'll roll with it.
Yeah, that's what I got.
So then we'll put that into the applet instead and keep everything shaded, middle right. So then if I do that, the area that I get instead is 0.8159.
That's what I get too.
Okay, so then with that information, do we still say that we are failing to reject the null hypothesis?
I think we're failing to reject the hypothesis. I swore I read something about this somewhere.
What did you say you think we should do?
I think we're failing to reject it.
Okay, well, it's a 50-50 shot. So we'll just do that, and if it's wrong, then we know otherwise.
Yeah.
Okay, so now we're back to the question about the insufficient evidence, though. And I don't know.
Oh, interesting. Listen to this. If the p-value is less than the A thing, we reject the null hypothesis. Conversely, if the p-value is greater than the A thing, we fail to reject the null hypothesis. The level of significance.
So we don't even know what that thing is. Oh wait.
The level of significance.
But it was 0.05.
Yeah.
Oh, level of significance. So it's 0.05. So that means our p-value is greater than that.
Yeah, so that means we failed to reject the null hypothesis.
Okay. Okay, what is your conclusion for this problem? So does that mean that we have sufficient evidence that the true population mean is less than 150? Since we failed to reject it. So that means that we're accepting it. Is that right? So then we have sufficient evidence that the true population is 150.
I think so.
Okay, that's what we'll do. Okay, there are two types of errors. What?
Isn't it less than 150? Isn't it the bottom one that we choose? Because isn't she trying to say, isn't her hypothesis that all grocery receipts or the mean grocery receipts are less than 150 over time?
The store manager suspects that the average has decreased. But she has two different hypotheses. So she suspects that the average has decreased. Hang on just a second. Okay, sorry. Sorry, Emily.
Oh, you're totally fine.
Okay. Which one involves rejecting the null hypothesis?
I'm just confused if we say that we have sufficient evidence that the true population mean is less than 150.
Oh yeah.
Or that it's 150.
Do you want me to do that? I'll do the one that we have sufficient evidence that the true population is 150, and you do the one that says is less than 150.
Okay, sweet.
So then for question 19, it's 50-50 shot again. So which one involves rejecting the null hypothesis when the null hypothesis is true? So when we reject a true null hypothesis, we say that a type 1 error was committed. So I guess type 1.
Solid. Okay.
A researcher decided that instead of using a level of significance of 0.05, he will use a level of significance of 0.01. Which of the following will be true? Oh boy. I don't know.
I think it's the probability that the null hypothesis is true will decrease. I know I read that somewhere, like it was talking about why that can't be 0. Why like 5 is a good number. I read that somewhere in the chapter.
Yes, that's true. Okay, so if the level of significance is 0.05, compute the probability of committing a type 1 error. I think this is in there too. Okay, it's in section 4.5 as the type 1 and type 2 errors. Okay, it says that, so when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.05 level of significance. So there's a 1 in 20 chance. So probability, 1 in 20. The decimal for that. So that still is just 0.05.
Yeah, I think I'm wrong on the one before that.
Which one? Oh, the 25. You're welcome. Did you get your lunch? Sorry, Emily. I have boys coming in and out of my home.
Okay.
Oh, man, my bad. No. Anyway. See you later. Okay, so back to question 20. Okay, this is in here.
I kind of think that 20 is the probability of a type 1 error will increase.
What? Okay. Okay. I don't know how we're supposed to compute the probability of committing this, because it straight up says in the chapter it's 1 out of 20, and it is what it is. Do we just put 0.05?
I'm gonna keep reading.
I mean, we can't. The only thing I keep on thinking, well, you can shove it in where the z-score is supposed to go in the applet, but I don't think that would be right either. That wouldn't really be logical. Okay, so Google says that fish-looking thing is called the significance level and is the probability of rejecting the null hypothesis, given that it is true. So it is the probability of rejecting the null hypothesis, which is a type 1 error. So that means that it is just 0.05 if Google is telling the truth.
Okay. I guess if we're wrong, we're wrong. 20 still has me stumped though.
What?
20 still has me stumped though, because now I'm thinking it might be the probability that the null hypothesis is true will decrease. So basically, I've been through every single possible answer that they've given us. So I just don't know.
Well, let's see what we can find. Okay, actually, Emily, if we take this, like, so for question 21, what I just said about the level of significance is the exact same as the probability. If that's true, then that means that the probability would go down. The probability of a type 1 error would go down. So what does that mean in reverse, I guess? Because I
I guess I don't get what type 1 and type 2 errors even are. Technically,
yeah, that's
not them.
well, a type 1 error is when we reject the null hypothesis. It has something to do with the p-value.
I wonder what Google says. Let's see. A type 1 error is a type of error that occurs when a null hypothesis is rejected although it is true. The error accepts the alternative hypothesis despite it being attributed to chance, also referred to as a false positive.
So
A type
when we reject a true hypothesis.
Yeah, so a type 2 error is a statistical term used within the context of hypothesis testing that describes the error that occurs when one accepts a null hypothesis that is actually false. So one is rejecting a true hypothesis. How are these different? How is rejecting a true hypothesis different than accepting a hypothesis that is false?
I don't understand it completely, but I'm pretty sure I know what the answer to 20 is. So with that information and with whatever we've talked about, so it continues on in the section 4.5, it says, if the probability of committing a type 1 error is very small, which I just said that it would be decreasing if it went from 0.05 to 0.1, then the probability of committing a type 2 error will be large. So I think that it is the probability of a type 2 error will increase.
Okay.
Does that make any sense, at least for that part?
Yeah, it does.
But I feel like I get where you're coming from, though. Like, it'd be nice to at least know some more information about these errors.
Yeah, because I think that I'm thinking about it backwards. Maybe.
Okay.
So, are we ready to submit?
Yeah, I just submitted mine.
One of mine says that the field must be a valid number, so I can't submit my test. What is it talking about?
Which question?
Question. Oh, I see what I did. It was on question 15. I accidentally put 2 decimal points in, which I guess makes it an invalid number.
Okay, I'm gonna pull up another quiz.
Hey, we didn't do too bad though, really.
No, we really didn't. Did you get like an 87?
I got like an 86.96. Any turn upstairs.
Okay, so it's kind of funny.
Right back.
Okay.
Okay, sorry.
You're fine.
Okay.
I'm just going back through my quiz and going through all the questions that I have like right and then which ones I have wrong.
So, did you miss question 18?
What?
Did you miss question 18?
Yeah, I did.
So that means we were both wrong.
Which one did you click? Oh, you did the less than.
Yeah.
Oh gosh. So we have insufficient evidence
Of some
of something. Wouldn't either, couldn't it technically be either one? Because she has two different hypotheses.
I'm not sure on that one anymore, because that was like one of the only ones that I was fairly sure that I knew the answer to.
So I got question 16 wrong too.
16?
Yeah.
Okay, I'm getting down there. Yeah, I also got 16 wrong.
So I don't know what we did wrong there. So the only two I think now that I don't know which one is right, 16 and 18. Everything else I think I either got right or I adjusted. Oh, for question 8
another one wrong.
or no, question 12. I got that wrong. I think it's the central limit theorem.
Oh, yeah, question 13.
Yeah.
It must be.
I looked up the definition for that again, and it says it's a statistical theory that states that given a sufficiently large sample size, that's all I felt like I needed to read. Sample size, because I think it may be different with the law of large numbers. I don't know that it says sample size.
One is like distribution and the other is like sample size or something like that. So.
Okay, so question, are there any others that you have questions about or that you didn't get right?
No.
So the p-value.
The p-value thing, maybe I'll just Google it and try to see. What was the significance level again?
It was 0.05.
Is it a one-tailed or a two-tailed hypothesis?
Two-tailed, maybe? Possibly? Because there's two different hypotheses. The null hypothesis is equal But the alternative one is that it is less than 150.
So
Yeah, I know.
now I'm getting 0.36812.
You did?
Yeah.
What'd you do? Do I even want to know, or should I just take your word for it and call it good?
Let's take my word for it. I'm not sure that it's right though, because I'm not sure if it's a one-tailed or two-tailed hypothesis.
I'm going to try to find, I read something about two-tailed and one-tailed earlier. I just don't remember where I read it. Okay, I found some stuff.
Oh, good.
I'll show you. Well, I don't know if it's going to be beneficial or not, but. Just came back. Oh, hang on. Try. Oh, wait. Seriously? Okay, it's working. So you see this thing? He's two-tailed. So maybe we didn't shade correctly? Because this is left-tailed, and that's right-tailed. So technically we followed a right-tailed situation, but it could be that it's... Where'd you go? Two-tailed. What?
Two-tailed, like on the applet. If you shade it that way, that's the number you get.
What is it? What's the number that you... Oh, the 0.3681?
Yeah.
Let's just try it. Unless you want to get really technical. I'm okay with my grade.
I'm chill with trying it because we got the z-score right, so we're like halfway there.
Right.
We're
So we'll
something.
just take the 1 off, because then that's 4 decimal places. So 18. Good old question 18. Well, we've got a 50-50 shot. So
No, it's less than.
maybe let's think about it.
It's the less than.
It's less than?
I'm like mostly sure.
Okay.
I need to retake
What?
so that I need to retake the quiz so that I can.
I'm submitting.
Okay.
%. If you round up.
It's gonna be that one, but I was like, it's less than.
No, it's 16. It's wrong still.
16 is?
Yeah, but you know, I'm good with the 96.
Question 16 asking us again?
It's, what is the p-value? And we have the z-score, so I don't know.
Okay. And what did you type in? Did you type in 0.3681? Or 0.368?
Well, 0.368 because with the 1 it's 4 decimal places. So I don't know what the story is on that, but it's not right.
I'm going to try a different number just for kicks and giggles. Let's stop broadcasting.